Hello, nice to meet you.
The Netherlands produce about 50% of all flowers in the world. The most famous one of all, the tulip, of course.
Flowers are really remarkable organisms. We've known for decades that they can actually communicate to each other through their root system.
For the past 2 years, Wageningen University has been working very closely with Google to use cutting-edge technology to look deeper into communication with plants.
Hello.
We collected an incredible amount of information. Using automated machine learning, we turned this information into a new rudimentary language, which is becoming more and more sophisticated over time.
And the more we listen to nature, the more we discover the amazing things it has to say.
Okay, Google, talk to my tulip. What do you want?
Water, please.
We've applied all this research into our latest product, Google Tulip.
2 granddaughters, Frances, who just had a second baby,
That is so interesting.
and
Finished. Nothing left.
More.
Yeah.
You promised more water.
At Keukenhof we're very excited about tulip technology. We like to know what tulips need, and what better way than to ask them.
I need water, more light.
Please improve humidity.
What is a Please come here. More space.
No more compost.
No water. Thank you. Who are you?
Why are there so many like
This way.
More light.
Of course, this is only the beginning. We're rolling out the Tulip language in the beginning of April, but we're already well underway with several updates.
Hello,
No.
cactus.
Leave me alone.
It's so great not to have a one-way relationship with the tulips anymore.
What is the meaning of my existence?
Tulip is a breakthrough in human-plant communication, letting users around the world communicate with any tulip.
Okay, Google. Play my favorite music.
Please welcome the founder and CTO of Google Tulip, Matt Feigal.
Okay, I'm sorry. Okay, no, nobody's really sorry. Hello, everyone. Thanks for joining our funny little talk here. Our very, very important product launch talk here. We at Google Tulip, it's been a really exciting time. We finally achieved this breakthrough in April in human and plant and technology that allowed us to communicate with our plants. At Google Tulip, we were lucky enough to work with the Google Cloud team and use some of their really great tools. And we're going to talk a little bit about the architecture of what we built behind Google Tulip, because we actually kind of built something. And I'd like to, hopefully, that you all as developers and techies in the audience, I hope you can keep in mind we're talking about some great architecture and some components and tools. I hope you'll see how these tools might be useful in the interesting and challenging problems that you're trying to solve, and we inspire you to go play around with them, try them out, or even contribute, help us out with Google Tulip. So, as a caretaker of plants and a flower lover, I've always kind of wondered, what are our flowers thinking? What do they need? Do they need more sunlight and more water? Could we help improve human and plant happiness together by improving this communication? And we finally made this breakthrough. We rolled it out with the help of Keukenhof and Wageningen University. Agriculture is a really important business in the Netherlands. So we achieved this goal to help everyone in the Netherlands through these tools. But then our team, Cristian, Lee, and I got thinking, why is this just limited to the large-scale tulip farms, the large-scale plant farms that have, 1 million tulips? What if a small gardener or a developer like yourself could play around with this stuff, deploy your own version of Google Tulip, modify it, tune it to your needs, try the things that you need with it? So we've created a lightweight open source do-it-yourself version that we are launching today at GOTO Amsterdam. It's actually on GitHub. You could go play with it yourself today. Okay. And we actually built a version of it that says, well, Imagine that you're a gardener or a do-it-yourself technologist. You don't have expensive sensors like the large factory farms. You don't have these root sensors and these scientists. Well, how could you do something like this yourself? And the answer we came up with was, at Google Tulip, we had years and years of sensor data, but what if we could do the similar information with your smartphone's camera, right? Using the inexpensive camera that you have instead of expensive root sensors, using easy-to-use serverless technologies, which are pretty much low-cost barrier to entry if you're going to start out playing around with stuff, and put them together into this package that you could apply. So we got to work on it. It's good enough that we're happy to open source it, and we're going to demo it today, and also talk about the architecture and components that hopefully you folks can use some of these. The user flow behind Tulip, I think, is important to understand. We've launched this thing called Tulip Translator. It's on the Google Assistant and on your phone and on the Google Home. User flow is probably something that you recognize, right? The user takes their smartphone, points it at your flower, and we send the images, we send the scans of the flower back to a back-end image classification service, right? Using some machine learning, we understand what type of flower is it? How is it feeling? Is it lonely? Is it dry? Does it need something? And then, once we've made that classification based on the information your smartphone is sending us, we pass that onto a conversational engine, which handles creating the conversation between us and the flower, handles the translation between Tulpish and English, and lets you do your own stuff. So this is kind of the user flow. Lei, Christian, and I each worked on a different part of this, so we're going to kind of talk about the challenges we hit, show you demos, show you what we built, the lessons we learned on that journey, because it wasn't always easy. You know that as developers. And hopefully one of these things will be the most important part for you that you want to take away and try. The most important part of this, obviously, is the machine learning part. We have to detect the image. If we don't know what kind of flower it is and if it's happy, how it's feeling, we're not going to get anywhere. When we were working on this project with Google Tulip, we had access to huge amounts of sensor data. We had access to scientists, machine learning experts, and they could use these really nice, great machine learning tools for data scientists to actually create our first translation models. But now, if we're building a lightweight, do-it-yourself version for you folks to use, you probably don't have those skills. And I, as a developer, I'm not a data scientist. I'm not a PhD in machine learning. So I'm a developer. It's going to take me a long time to get up the road to do that. How do I solve this problem efficiently? Well, there's also a whole bunch of image classification tools out there. Many, many vendors have their image classification tools. If you're going to do a project like this, the first thing you should do is go test them all. Go try them all out. Google Cloud's is Vision API. And it's very simple to use as a developer. You throw an image at an API, it tells you what's back in it. What objects are in it? Is it a car, a human, a dog? Is there character recognition? That's great, but none of those things are relevant to our project. Our project is about plants. And it'll tell us it's a plant. It might even tell us correctly what type of flower it is. But we're scientists with plants, and we know a lot about our plants, and we know what we need to get out of it. So in the old days, if I was going to leave this API model and bring my own data and retrain properly, I'd have to fall off this big cliff and hire a machine learning expert or teach myself these skills. To learn about the tool sets over here, I would probably have to collect a huge amount of data because I'm starting over from scratch. I would have to spend time training, figuring out the bias and the challenges and what's wrong with my data. It's a big investment compared to just doing this. So how do I solve that? Well, luckily there's a nice middle ground. Our tool is called AutoML, and Google Cloud's tool is called AutoML. We're pretty happy with it. And what it allows is to bring my expertise in plants and a smaller data set and retrain something on top of the pre-trained models that really meets the needs of my projects. And that's actually what we used in Google Tulip. And that's the part I'm going to show you right now. So if we switch over, there's kind of 4 phases. If you see in the top left, there's kind of 4 phases of any machine learning issue you're ever going to work on, right? Gathering your data, in this case, a lot of images. training the model that you plan to use in your application, evaluating your model, how does it work? Does it meet our needs? And then actually starting using it to make predictions. So that's the 4 tabs you see up here. If we just start on the data, first thing we need to do, of course, is bring our data. We can do this by, uploading stuff from our computer. Probably we have more images than that makes sense for. We can put stuff into a storage bucket and import them here. If we have pre-labeled them, like if you've already got some expert who's sorted them into folders or has a CSV file with the categorizations, you can do that. And a lot of our stuff that we got was pre-labeled. But then we reached out to our colleagues. Everybody started donating pictures, sending us pictures. And we had a lot of unlabeled stuff that we needed to classify. So that was pretty easy. The user interface allowed us to just pick a few and say, yeah, these are cactuses. So it actually just helped me in my gathering data classification process. We've done this on approximately 2,500 images so far. Let's see, there's a tulip here. Let's tag some tulips. You could just farm this out to a few of your friends to work on it together if you don't have an automated way to do it. All right. So that's kind of the gathering the data. Actually, we started with kind of some open source data sets, and then we collected a lot more with our smartphones. Now we actually have to go train the model. We have to train it. And that means we're going to set the computer doing its trial and error machine learning thing to find the right solutions. We found that we started out with the free training, which takes about an hour. That sounds like a long time compared to doing some local stuff on with Python on your computer, but we're actually very fast for the high quality model you're getting. The reason that it's so high quality with such a short time is what's happening here is we're using something called transfer learning. Now the machine learning people know what that is. As a developer, all I need to understand is Google's core image model, the pre-trained model, is well trained on millions of images. And it gives a pretty good answers to general questions. But I, as a plant scientist, I'm the expert there. I've got very specific questions. Is it damaged? Is it lonely? What type? What color? And I want that information out of these images. So I've uploaded about 3,000, and I'm training a very specific plant model on top of that generic model. And then I can just use that very specific plant model that meets my needs or my goals. Hopefully you as developers can kind of see you're probably struggling with your own challenges where a basic API doesn't quite meet your needs and you need to tune in. Also, while building Google Tulip, we discovered that if we used more nodes, we'd end up with a better result. It's natural. It gets more crunching, more trial and error. We found that using the free 1 hour testing was really good for the iterative testing. Let's just try it out, see how it works. And then eventually in our releases, at our regular release cycle, we would train a higher quality model. Also, we found we didn't need to do this, but we found a nice thing here where we could just host our model in the cloud, which means when it's done, it automatically gets deployed to an API that we can call and get answers. Or if we knew that we wanted to do some edge computing, say we're working with some tulip farmers in far distant areas that don't have good internet connection, I can already train a model that's specialized towards the type of, towards the trade-offs that I need to make for working completely offline on the type of hardware that I'm aiming for. So I can already cover that here. I think I'm going to skip training the model because you don't want to wait an hour. Instead, let's go look at the next phase let's look at the next phase, which is the evaluating a model. So this is the evaluation tab, and after I've trained it, I want to see how good is it. I can already see this is our high quality one. It's a little bit better than the free one, but it's 99% accuracy, which is pretty darn good considering I only sent 3,000 images in. That's a really, really big change compared to trying to do it myself and the accuracy levels I'd get. But let's say, so how does it know what the accuracy is? I didn't do any manual training or anything. This tool automatically, just for me, pulled out a sample set of images, which my data scientist would have known to do, but I as a developer would have forgotten, right? My data scientist would know that you need to have a separate evaluation set. This tool did it for me, and then did its evaluations against that. I, as a developer, would have probably screwed it up the first time, not known it, had to retrain models, invest time in learning the proper terminology and what I did wrong, what the tool sets are to do that. Some other things we see here when I'm evaluating the model is it generates a confusion matrix. This is where the model is getting a little confused, where it's not sure what it is. There's a little bit of confusion between tulips and roses. Maybe some cleanup to be done there. It's a great way to spot problems in your data, problems in your things that you didn't expect. The one I see here is, whoops, what did I click on there? Uh-oh. Okay, what I saw there is a difference between the dahlia and the aster. It couldn't figure out what the difference was. Now, that kind of makes sense, but maybe I wouldn't have spotted it before. Dahlias and asters are actually really closely related. They're a similar family plant. So maybe my data is tagged wrong. Maybe I need to go check my data more carefully. Or maybe because they're so closely related, I need to invest some time in getting more examples of those that differentiate between them. That's a good thing that I wouldn't have noticed otherwise. And then when I'm done with that, probably there's no testing like actually trying it yourself, right? So we can upload an image. I'm just going to upload the same image, so sorry, it's not going to change. Let's upload an image of tulips. Let's run an evaluation on it, and it'll actually tell us. It's just going to call straight to the API that it's got running for us. And you'll see it's got 87%. Not quite as high confidence as I want that these are tulips. There's some background images here that probably has something to do with it, but all these images are going to have weird backgrounds, so it's kind of important. I, as a developer, can probably, if I'm building an app on this, would make some decisions. Is this what's the confidence threshold I want to see before I proceed and take action? So then when it's time to embed it in my app, like I said, it's hosted already as an API that I can just call. I can create a payload, send a picture, and get a result. If I wanted to embed it in my application, there's some sample Python code, other easy ways to do that. So that's the end of my AutoML demo of the most important part. Just a little comment about the future. If any of you are IoT experts and want to contribute to Google Cloud, to Google Tulip, once we get somebody involved in our project that loves IoT and sensors and gardening and actually can contribute a cheap way that we can get these sensor readings that we had from the very expensive scientists at Wageningen, we can start getting sensor data in again, instead of just using the images, which, to be honest, are not the best way to tell what a tulip is thinking. We can actually start doing the same techniques of AutoML on huge amounts of structured data. So say we have sensor data, real-time data, IoT data, streaming data. We can actually run the same techniques where AutoML will test out a bunch of different machine learning models, different architectures. It will challenge or champion them. For us developers, that's just called A/B testing until it finds the results. And with the same ease, we'll be able to work on more structured data. So that's the end of, I think, the most important part, the machine learning part, to talk about our back-end infrastructure, how we actually built it and run it, so the place that it runs, where our team can focus on new stuff. Let me introduce Cristian Hees, our VP of Infrastructure at Google Tulip. Welcome.
There you go. Welcome everybody. I'm really excited to be here. And now I would like to talk to you about the most important part actually. This whole machine learning part, yeah, it's cute. But the most important part about this whole thing is, of course, how do you actually get everything running? You need to actually have an online application, a website that people can call on their phone. And that thing needs to make backend calls. And then the AutoML thing comes in, sure. But this is the core of the thing, right? This is the most important part. So this outline part is what I'm going to be talking about. And I'm a developer, and as a developer, I want to write my application. And I want to write my application in a language that I'm used to. And I want to use the frameworks that I used to, and I want to use all those tools. Okay, this is the application I want to build. Then I want to deploy that thing. And that's pretty much all I want to worry about. So I don't want to worry about anything else like server configuration or maintenance or scaling or anything like that. So the thing that we're going to use here is Cloudrun. And Cloudrun is a Google Cloud product. It's recently launched, and it's a serverless platform. So Google has had a lot of serverless platforms over the years already, ranging from Google App Engine, Google App Engine Flex, and Google Cloud Functions. And this is the next product that we have. This is sort of building on top of all this knowledge from these years of experience that we have. It's an auto-scaling platform, so it can scale all the way to 0 if you have no traffic coming in. Then you don't use any servers. You don't get billed for anything. There's nothing there. If you all of a sudden have Valentine's Day and everybody starts scanning plants, then you have a lot of traffic incoming. It scales automatically for you. You pay for that. It automatically scales down again the next week. Then nobody cares about flowers anymore. So it's auto-scaling there. But if you look at functions and serverless, a lot of people think, okay, I have to write this little thingy, this little specific function in a particular language or framework that I have to use, and that's what I need to do. This is not it with Cloudrun. With Cloudrun, any web app you can put in a container, you can run on Cloudrun. So it's not just functions. So you have your existing application, you just add a Docker file to it, upload it to Cloudrun, Google handles the rest. So that's the nice thing about Cloudrun. So I guess everybody is familiar with Docker. People familiar with Docker? Okay, this is the right public, good. So you have an example Docker file like this. So a lot of people have seen this. Then you start with a base image. In this case, we have a Node.js application with TypeScript. So this is what we like. And for this project, we used that. Then we added some dependencies. We installed the dependencies. We copied the rest of the application. We build it. And eventually, we run it. That's all that goes in a Docker file. And I guess most of you have seen some form of like this. So this file you add to your existing application. Then, two things that you're familiar with if you're using Docker already. If you know Docker, then you need to do a Docker build. In this case, we tag it with GCR, which is the Google Container Registry. So then you say, okay, we tag it with this particular version, with this thing, and we give it a Tulip name for the project. And then we push that Docker container to the registry. And then after that, the magic happens. You say gcloud run deploy Tulip. And then you give it this specific image that you just built. And then it's going to be automatically deployed to Google Cloud Run, and it's ready for people to serve. That's all there is to it. That's super fast, and that's really nice for a developer. So you write your code in whatever you're used to, add a Docker file, deploy, go. Cloud Run. But of course, as a developer, I'm kind of lazy with this stuff. I don't want to do these steps all the time. So what I did now as the next thing, I set up a build trigger. So here we have Cloud Build, which is something that we have in the Google Cloud Platform. You can say you set up a build trigger. So in this case, I set up a build trigger for Git. So every time I push code to the Cloud Run branch, this trigger automatically picks it up, builds the container for me, and automatically deploys it to Cloud Run. So CI/CD pipelines and stuff like that, you can easily set that up with a couple of clicks here. So that's the next thing that I implemented there. So now, as a developer, I'm happy. I have a nice flow. I have my working application. I have the Docker file. I know how to deploy it, can quickly get it running into Google Cloud Run. All right, but now you get to the real world, right? You have a lot of these big companies. They say like, oh yeah, well, we're this big company and we have a lot of regulations. Like a lot of things, like, oh, there's a lot of PII data when you're talking to plants, like plant identifying information, right? And we have to deal with the GPPR, the General Plant Protection Regulation. Yeah, it's all very hard and stuff. And yeah, what are we going to do? We also have this existing Kubernetes infrastructure that we want to use. So yeah, this Cloud Run is all nice and it works exactly what we want. But this is where we are. This is what we have now. What are we going to do? So solution is you can still use Cloud Run because Cloud Run is actually built on top of Knative. So Knative, what Knative is an open source software project. So just like Kubernetes is an open source project and GKE is the managed version of it, and TensorFlow is an open source project and AutoML is a managed version of it, and we have a lot of those things at Google. Knative is an open source project, open source building blocks for serverless on Kubernetes. So this open source project makes sure that you can have serverless on top of Kubernetes anywhere. So anywhere you have Kubernetes running, you can use this. And Cloud Run is just the managed version of this, which makes it very, very easy to work with and easily set up. So as a developer, this whole workflow, just add Docker file and deploy. That's what Cloud Run completely works for, gives you with Knative. You can do that on your own Kubernetes clusters. So the way that works is you can have either the completely managed version of Cloudrun, managed completely by Google, or you can have Cloudrun on GKE. So GKE is the Google Kubernetes engine. If you already have like a Google Kubernetes cluster, you can just say, okay, add Cloudrun to that. Google installs it for you, and then you can deploy to your own Kubernetes cluster there. Or if you have any other Kubernetes cluster anywhere else running, you can also use that. Install Knative on it. It's a little bit more work to do it to set it up yourself, but then you have the same developer experience. People can use the same tooling to deploy the same serverless infrastructure then. So the way it looks like then is, for example, here we have the dashboard. Here we see that the Tulip version is deployed 4 minutes ago, and it's running on our Cloudrun cluster in Europe, and it's serving Tulip dev, and that's all there is to it. So now that we've talked about the AudioML part and the AI part, and that I've shown you how we run the infrastructure, I would now like to invite Lee Boonstra, the VP of Engineering, I have to say it right, the VP of Engineering of Google Tulip. Welcome, Lee.
Yes, thank you, Christian. All right, and now it's time for the most important part, the conversation of the tulip, because we want to know what these tulips are thinking and, yeah, how we can communicate with them. Right? So how does this work? Well, you might have seen this, especially when you're watering your plants, and you give them water, then suddenly they start shaking. Well, that's actually the plant telling you, like, thank you, I'm very happy, or please give me more water. And we at Google Tulip, we've been studying these plants for years, and we figured out, like, yeah, there are lots of different ways that tulips are trying to say things to us, and we want to map this to real conversations. How does this work? Well, we point our mobile phone camera on the tulip so we can notify all these movements of the tulip. With AutoML vision classifier, we detect what type of plant it is, and we kind of make the connection with the plant. So in this case, well, it's a tulip. And then we have we see a button on the screen where we can press it and we can start having the conversation. We can talk to it. It goes via spoken text, goes into the application. The application talks to Dialogflow, Google Dialogflow, which is a tool for a conversational UI. You create your own conversations in this tool, and it does intent matching. And based on that, Dialogflow will return on us the results, and we map that to audio files. Here you can see Dialogflow. I collected many conversations, and I wrote this in the tool. And an intent, that's basically like a kind of a chat flow, where we train it with a couple of user phrases. So in case of the chat flow, I am thirsty, I could say like, well, do you need some water? Are you thirsty? Do you need a drink? Typically, I would say take 10 to 15 training phrases, and that's a good practice, and then you start training this intent. And Dialogflow works through intent detection. So once it hears me talking, or when I type things, because Dialogflow is also being used for chatbots, then it just looks into all the intents, which intent has the highest match. That is the response where, the response that will be returned. And you can type in the responses in Dialogflow itself. And because we work with text-to-speech and speech-to-text, it will translate this spoken text to audio files, which we will hear in our app. I'm going to show you a demo, and then you will see the parts that I just highlighted. So let's have a look.
Ready.
Yeah.
Oh,
okay.
Reload.
Just reload. Okay, cool. Yes. So I'm first going to scan the plant. You see, like the app is thinking, oh, great, it looks like it's a tulip. Yeah. Okay, look, if I would have shown it to a cactus, it would see it's a cactus. If I would show it to a rose, then it notices it's a rose. Hi, tulip. Hello, tulip.
Hi there, I'm a flower. What would you like to know?
Well, what is your favorite color?
Blue is my favorite color. It's the color of water. Would you like to ask anything else?
Yeah, what color are you?
Could we talk about something else? For instance, ask me about my newfound fame or how you can help me grow faster?
Fame?
I'm sorry, I wasn't listening. Could you ask about my childhood or what I need to grow?
What do you need to grow?
More light. What do you like more, water or sunlight?
I love sunlight.
Could we talk about something else?
All right.
My newfound fame or how you can help me grow faster?
Yeah, so you got the point. You saw how it works. And the way how we've built this is like we created like a client application, which is the front end, and a backend application. We use the client application for the HTML5 microphone. So we use the browser microphone through JavaScript. And actually, that's actually the most tricky part to build an app like that, because you would think it's machine learning or anything, or like conversation, but the actually hard part is to capture the microphone from the HTML client and bring this to the backend, because the backend, the Node application, is connected to Dialogflow SDK. And the front end has probably different encoding than the backend has, so you need to make sure that these encodings match when you are collecting the stream, and then you can push it to Dialogflow. And since we use in Dialogflow text-to-speech, then it will automatically return the audio object as a string, which we put into an audio buffer, and then we can send it back to the backend where it will play the audio file. Here you can see the piece of code. So you basically are creating a request, and this is very important that you set the settings right. So you need to set the sample hertz, which need to be the correct one compared to what the client HTML5 microphone gives you. And now you say like it's linear 16. You need to specify the language code. Now obviously tulips, they talk tulips. It's a plant language, but we map it to English language because that is the language that Dialogflow needs to return. So we also define that in the audio config. We say like, well, it's 48K, and we need to specify also a voice. Well, we figured tulips, well, they have a bit of a high-pitched voice, and they're more like female gendered, so we chose a female voice. And once we have the audio output config, the input config, then we just need to specify the audio stream as input audio. And then we call the detect intent with the request, and that way it knows, okay, this is actually a speech-to-text object. We will return audio back. If I would return text, in case I would have built a chatbot, then it would return me the text intent match back, and the confidence level of the hits that it made. And with that, I'd like to welcome back Matt and Christiaan on stage, so we can wrap this up. Hey.
So thanks everyone for joining us. In case you were a little confused, the Google Tulip project was an April Fool's joke. But we were actually surprised with these tools like AutoML Vision, with Cloudrun, with Dialog, some of these text-to-speech stuff, how easy it was with these serverless tools to get pretty close to a working model that you could then say, oh, well, we need to extend this into a production model. So we were happily surprised with how easy it was to create this.
Yeah, and also what we saw is like as we were building these demos and we were showing it to our colleagues, that they showed these apps to their kids and they loved it. They really saw it as a game. So we thought like, yeah, we should do something with this. So we put it on GitHub and we invite everybody else to contribute, because maybe you have crazy ideas like building apps for trees and you want to figure out what trees are thinking and if they like your hugs.
Yeah, so the code is on GitHub. You can find it on github.com/Google Cloud Platform/Tulip. Tulip.dev, that's where the application runs. And you also have the video that we saw in the beginning. If you Google for Google Tulip, I'm sure you're going to find it as one of the first results. We also have a technical blog post, which also, again, if you Google for Google Tulip, you're going to find this post. And the nice thing about this whole thing is that, like, of course, my part was the most important part, right? But each of us thinks our part is the most important part. So pick whatever part is important to you and see in this repository like which part is actually interesting for you and matches your situation. I think there's something for everybody here. Thank you.
Thank you so
Thanks.
much.
Oh.